This is a single replacement reaction.
This solid has no particular smell. It is silver and metallic and chunky. This is the Lewis dot diagram for zinc.
This aqueous solution is clear and has no smell and is colorless. Here's the dot diagram for sulfuric acid.
Here is the reaction between zinc and sulfuric acid.
H2 is a colorless, odorless gas. Zinc sulfate is a colorless, odorless aqueous solution. These are the substances before the reaction. The zinc is a solid and the aqueous sulfuric acid solution sits at the bottom of the test tube. In sulfuric acid, hydrogen and sulfate have a 2-to-1 ratio with twice as many hydrogens as sulfate.
After we put the zinc in the sulfuric acid, we corked the test tubes so that we could keep the hydrogen gas from escaping.
On the left side of the diagram, you can see the zinc breaking apart in the sulfuric acid, turning into the zinc ion, which has a positive charge of 2. On the right side, you can see the hydrogen breaking off from the acid and becomes H2.
After the reaction is complete, there is an aqueous solution of zinc sulfate sitting at the bottom. Zinc and sulfate bond well because the zinc ion has a charge of positive 2, and sulfate has a charge of negative 2. Zinc and sulfate share ion-ion intermolecular forces, which means that their intermolecular forces are strong. The H2 gas, because it only has dispersion forces, means that it has weak intermolecular forces, so it cannot mix well with the zinc sulfate.
In order to prove that hydrogen gas was actually released during the reaction, we lit a match and held it over the open test tube. An interesting discovery that we made was that the hydrogen gas makes a popping noise when coming into contact with the fire.
Hold it
Take
right.
it off now.
Okay, go ahead. Now you're gonna go. Get ready. Just go. Take it off.